slide allows you to experience falling under gravity, but with some control provided by friction. The friction generated while sliding down a surface depends on the properties of two different things: the slide itself and the surface of the pants or cardboard or other material that we're using to slide down it. The steeper the slide is, the more the force of gravity pulls you directly down the slide. And the less angle the slide has, the less that gravity, which is down, pulls you down the slide. This slide starts off with a medium steep drop at the top, then curves around and goes a little bit less angle down, and then it hits a real drop to get you some speed for the final flat run out to the end. I'm going to measure the speed of a person on the average coming down this slide. And then we're going to have the people change the friction of the sliding. 3, 2, 1, go. Uh, 3.8 seconds. And so it's 40 feet in 3.8 seconds. That's just a little under 7 miles an hour. Okay, Eric, on cardboard. 3, 2, 1, go. Woo! That was faster.
I was jamming on that one. I actually went all the way to the end of the slide and actually flew off a little bit on that one.
So it took them 3 seconds, and that translates to about 8 miles an hour, substantially faster.
With just a little piece of
Cardboard. Yeah, it's not as strong now because it's been...
Yeah. So what happened?
There's enough friction on this where actually you can smell a little bit of combustion from the paper on the bottom of this.
So this time, we're going to use a ball, and a rolling ball has a lot less friction than a sliding person. So this should be the fastest of all. 3, 2, 1, go. So that was really interesting. The ball rolling, colliding with the sides, lost some of its energy. The speed was just like Eric as he slid down. It was 3 seconds, and that's about 8 miles an hour. So I'm very surprised. So now we're going to try a different experiment. We're going to see what is the effect of the mass of the sliding person. So we have a lighter mass person, Jane, and a heavier mass person, Eric. So we're going to race them down the slide, see who wins. I predict the heavier person might win this race. Okay, ready? 3, 2, 1, go. Oh. So Eric, the more massive person, won. However, there's some question. Are both slides the same? One slide at the top is steeper than the other side at the top. And when the slide is steeper, you accelerate faster and get a little more speed. So this time, we're going to have them switch sides. Okay, 3, 2, 1, go. And that time, Jane won. She came by the finish line first. So I think it showed that the steeper start to the slide had more effect than the different masses of the people. The two slides are not the same. One of them is a little steeper at the beginning than the other. And that steepness at the beginning gives that person a little extra speed at the start. But they keep that extra speed for the entire run down, and that makes them finish first by a lot.
So Jane's got a tail feather here. That could provide some friction.
I'm gonna predict that the chicken is first, because the chicken is on the slightly steeper slide. Ready? 3, 2, 1, go! And the chicken won in the slightly steeper slide. So this time, we're running a control experiment. We're gonna switch sides and see that this time the gorilla's gonna win, I predict, because the gorilla's on the steeper side. 3, 2, 1, go! Whoa, the chicken won again! So the chicken suit must have lower friction than the gorilla suit. So we did a controlled experiment with the chicken and the gorilla. We had them switch sides, and that time the gorilla was on the steeper, faster slide, but the gorilla came in second. And that tells me now that the chicken suit had a little less friction. So the person in the chicken suit, even though they were on the slower slide, went faster.